8.2 deals with identifying relationships. We're going to be doing some comparison with fractions and decimals. Decimals are pretty easy for us to compare. Fractions are a little bit harder, and that's what we're going to focus on. So go ahead, take a moment to read the reading strategies on the front of your worksheet. And it just talks about comparing fractions and benchmarks, what we could compare them to. And if you don't understand benchmarks, take a look in your book. It kind of talks about it. Benchmarks, what we're going to use mainly is 0, a half, and 1. We can also use benchmarks in between there, like a third and a fourth, or 2/3 and 3/4, if we know that it's close to that. So we're going to look at number 1 down below. It says, what is a benchmark for 35/67? Sorry, let me move my papers. I'm going to say benchmark for 35/67 is a half. Because if I multiplied 35 by 2, I'd be at 70. So 35/70ths would be a half. So I'm going to say it's pretty close to that. A benchmark for 11/13 is 1. 11 is almost as big as 13. So when your numerator is close to your denominator, we put that benchmark at 1. So now we have to comparing using our inequality signs. And I'm going to say, because of my benchmarks, that 35/67 is less than 11/13. Okay, what is a benchmark for 17/20? Again, I'm going to say 1, but depending on what I'm comparing it down below, I might have to say, 3/4 or 2/3, somewhere in that range, just in case. But when I look down below, I can see that 6/35 is really close to 0, or really 1/4, because 6/30 or 1/6. But I'm trying to use benchmarks that are common, fourths and thirds. That being said, even if I use these benchmarks, it's pretty easy to tell, though, that 17/20 is greater than 6/35. And that's just number knowledge, okay, just paying attention to what you're being asked. So it says use benchmarks to compare these and explain your thinking. I'm right away going to say that 19/21 is greater. So 21/40 is less than 19/21. Here's my reasoning. 21/40 is really close to a half, and 19/21 is really close to 1. So benchmarks are going to be the easiest way to compare if you can use them. We run into problems, however, if you turn your paper over, when our fractions are a little bit closer together and they're not spread out to hit those benchmarks far apart. So we're going to learn a couple different methods. Method 1 is to multiply to find a common denominator. So the first way to find a common denominator is just to multiply your two denominators together. So I'm going to multiply 9 and 13 to find a common denominator. So 9 times 13 is 117. Let's get that locked. 7/9, I'm going to multiply both my numerator and denominator. This is what we did in 2.1 by the same thing. I'm going to multiply them both by 13, get 91 117ths. And 4/13 I'm going to multiply by 9 and get 36 117ths. So now I'm going to be able to just look at my numerators. When your denominator is the same as it is in this case, I can just look at my numerators. So I'm just going to compare 91 and 36 from my numerators above. Since 91 is bigger than 36, then 91 117ths is bigger than 36 117ths, which goes back to the original 7/9 is greater than 4/13. I wouldn't have done this problem this way. I would have used benchmarks, because 7/9 is close to 1 and 4/13 is definitely less than a half. I already know that 7/9 is larger. I didn't have to go through all of that. So pay attention, and if you can use benchmarks first, use them. They're way easier than working out all of the math. Method 2, finding the least common denominator. Okay, so I'm going to list multiples of the denominator, which are 5 and 3. Whoops. So this being said, that's the denominator. So 5, 10, 15, 20, 25, so on. 3, 6, 9, 12. It didn't leave me enough room, but I should keep going on to 15 to find that the common denominator is 15, which in this case happens to be just multiplying my denominators together as I did in method 1. So 4/5 is going to get multiplied by 3, and 2/3 is going to get multiplied by 5. Okay, so 3 times 4 is 12/15. 2 times 5 is 10/15. And if I look back for comparisons, 4/5, its benchmark would be 1, and 2/3 benchmark would also be 1. So that's why I kind of have to go through this method. So now I'm just looking at my numerators. 12 is greater than 10, which means 4/5 is greater than 2/3. Little trick here. If your numerator and denominator are 1 away, as both of these are, the one with the more pieces to the pie is going to be greater. Okay, the next way we can do it is decimals, and we learned how to write decimals in 2.1. So you can just take 3 divided by 4. You know the decimal to 3/4 though is 2.75. And 2 4/5, if I take that up to tenths, it's 8/10, so that'd be 2.8. Now it's easy to just look at my decimal portion of it. 75 1/100ths or 80 1/100ths. Remember there's that 0 there. We don't always write that. It's understood. So 2.8 is bigger than 2.75. So therefore 2 4/5 is bigger. Which, by the way, I have a difference of 1 between my numerator and denominator. How many pieces of pie? This has more pieces of pie. It's going to be the greater one. Another way to do this comparison, line these up so that you have the same amount of decimals. Now I can see right away that this decimal 8 is greater than the 7, which makes the 2.8 greater. You guys have practice B. If you watch the video, you know to only do the odds when you come in tomorrow and just have the odds done. Good luck.